Good afternoon. I'm Steve Haigh, the Chief Technology Officer at Tokenovate. Today I'm going to talk about the work that we do at Tokenovate, in particular around tokenization of real-world assets, cash, and how we deal with atomic settlement, and how we tokenize that on a public blockchain in capital markets. So first up, many of you probably don't know what capital markets is. Capital markets is a part of the financial services industry where governments, organizations come together to raise money to do the work they want to do. So think government debt, it's government bonds, companies issue equities, stocks that we invest in. That money underpins a lot of the everyday stuff that we don't think about, but your pension fund, that money is hard at work in capital markets. Your mortgage comes from capital markets. Your car finance comes from capital markets, underpins everything. Those government bonds, they're being used by governments to build hospitals, maybe, run schools, repair roads, also maybe. It's a big industry, big banks, big asset managers. It's very fragmented at the moment, lots of systems, not well connected, lots of humans getting involved, lots of manual processes, lots of reconciliation of trading data that results in large teams having to run around and do a lot of manual processes. We find that legal and economic pathways are quite detached, so the legal constructs of the trades are detached from what's happening economically as assets are moved around. And we have what we call T+2. So T+2 is where we talk about settlement times. So typically in a trade, it can take up to 2 days for the assets to land after a trade has been settled. You might experience this when you're trading your own stocks and shares. It takes 2 days to get your money. It's the same for institutional finance and in capital markets. And that slows down the markets. It means that liquidity is trapped for a period of time. That money can't be put to work. Those assets can't be put to work. It introduces a whole load of risk to the banks, to the asset managers, and drives costs. And that affects all of us. Those slow collateral movements, they reduce the speed at which markets move. It stops the innovation of capital in the market, the introduction of new financial products, the way that systems can work, and how that liquidity is actually utilized. We've adopted a blockchain, the DLT. There's a lot of that going on in financial services at the moment, but it's disconnected from trust. And so in capital markets, regulated trust is absolutely paramount. Privacy, regulation, trust. There needs to be a level of transparency, but it's very measured in capital markets. And that's where we believe that a blockchain can come in and help. We bring a very legal-first view of that to the world. And so the Tokenovate ecosystem, so Tokenovate is automating post-trade in capital markets. So the way to think about us is we are financial market infrastructure. We plug into the back of stock exchanges or financial market infrastructure, and we automate the post-trade phases of a trade. So trading is done at a stock exchange. Typically, we're talking about capital markets, so it means derivatives, it means securities financing transactions, not the sort of trades that we would do as retail investors. But for example, a derivative, two parties might take a position on the interest rate of a certain currency going up and down over a 10-year period. That results in cash flows. Effectively, people are taking a bet or they're hedging on where the underlying asset might go. We take in those instructions when a trade is placed on one of those platforms, and we take over and we do the automation. The way that we do that is we take in a lot of messy data on the right-hand side around assets and trade messages, legal agreements, and market data, and we ingest that into the core of our lifecycle engine, which is built around the common domain model. It's an industry standard. It's basically the codification of legal contracts. It means that the workflows are legally proven. They're backed by law, by contracts. They're well proven, and we act on that. We're able to automate on that in our software, and what that results in is standardized settlement instructions coming out of our automation engine, which we pass into our settlement layer. And those standardized settlement instructions are also based in law, and it allows us to move assets around in the real world and to use a blockchain to facilitate that tokenization. Common domain model is open source. We're working with the BSV blockchain. It's a UTXO blockchain, and we've chosen it for specific properties that we believe are extremely valuable for what we do and for capital markets. So why do we use a public blockchain, public UTXO blockchain? It's decentralized. It provides a layer of trust where you're not having to trust any individual party. There are a lot of private blockchains and financial services today that are run by banks or by certain cohorts of banks. This provides a third party, it's transparent, and that trust is paramount in providing that visibility around have my payments been made, when did it happen, was it locked to the right people. That brings neutral infrastructure. We can prove the provenance of those transactions, so unlike account-based blockchains, this is highly parallelizable. Everything is represented as a little data packet on the chain in itself. We call that a UTXO, it's an unspent transaction. But it leaves a trail behind it, the history of all of the things that have happened in that trade, that transaction. So we have this immutable ledger that we're building over time, which gives us that provenance all the way back to the genesis of the original data packet or the coin that we use. It's programmable, so our settlement instructions are programmable. They are programmed by the common domain model, by our lifecycle automation. And then we pass that into the blockchain. So our tokens that we are going to create, and you're going to see some of those today, are built around the rules that come from the legal framework above. It allows us to do atomic settlement. So that's key in what we're doing here. So delivery versus payment is essential in capital markets. I'm paying you as I deliver the asset. It all happens atomically, and we do that in a single transaction. So we represent the assets as 2 tokens, we put it through atomic settlement, and I've got settlement having happened. That's critical. Privacy with control is really important, and the way that we deal with that is we use a technique called Merkle proofs, where we create hashing trees. All of the data we put on chain is not readable, it's not transparent. The privacy is really important. And then all of those transactions that go on chain are individually locked with a unique key that is derived from a master key that belongs to a certain organization. And it scales. I mean, the BSV blockchain is one of the attributes we like is the scalability of it. The team there do some amazing work. The protocol has been proven to deal with 1 million transactions per second, which is well beyond what you might find with a BTC network or an Ethereum network. And just as a point of reference, if you think about the Visa payment network, so the Visa card in your wallet, roughly 70,000 transactions per second. So this is order of magnitudes beyond. It's designed to be a global payments network, and it has that sort of scale. They have bursted higher. In the last year, we've seen sort of 3 to 4 million transactions per second. So it's got that capacity, it's got that privacy, it's got that security, and it's got the resilience that we need in capital markets. We're going to underpin the way that economies work on a blockchain. So it's got to be resilient, it's got to be highly available, and you get that through the decentralized nature of the network. And so the continuity of the network is guaranteed. It's censorship resistant, so nobody can kind of interrogate it. It's a public protocol. All of the software is in open source. You can go and look at it, you can go and examine it, and it works. Going back to capital markets, my requirement is to provide that security and privacy to my clients. And my clients they're the stock exchanges of the world, the London Stock Exchange, for example, but it's actually the parties that are trading on those platforms that's really important. So if you think about the big banks, the JP Morgans of the world, the Goldman Sachs, you think about the asset managers like BlackRock, their data is going through our platform, we're facilitating that trade, and we're putting those assets on chain. The way that we deal with that is different layers of security and privacy. At the top, we start with our cryptographic privacy. So I talked about Merkle trees, but we don't put any asset data on chain. There is no contractual data. There's no identifying information on chain. It is a Merkle proof of data that we hold securely in our own system. And then when we are putting transactions on chain, we sign them using a derived key scheme. So we use elliptic curve cryptography, which means you've got a master key, and then from that you can mathematically derive a key which can be related back to the original key, and we use that key to sign the transaction securely to put it on chain, which means if you were to look at Public Block Explorer, and we'll see a little glimpse of one later on, if you were looking at all of my transactions, the data in the payload of the UTXO, you could not read, you could not understand, you could not reverse engineer, and also the way it is locked, you could not unlock it, and you couldn't work out any patterns with other transactions on the chain. The key management, we use industry standard hardware security modules. These are things that are already in banks or in other industries, but it means that all of the cryptographic functions are locked away in something that I don't own, I don't control. We create our root keys there, they never come back out, and the derived key scheme is handled inside that box, which means I'm never asking for cryptographic key material to leave the box. The box can be part of a customer's infrastructure. So if I'm Lloyds Bank, I'll run my own HSM, I'll connect it in. I am custodial over the keys and the key infrastructure, which is really important. And what we're doing is we build the transaction we want to put on the blockchain. So if I'm minting a token or transacting tokens, we build that transaction, we pass it into our hardware security modules. What we get out is a signed transaction we can then broadcast onto the blockchain. Then the blockchain takes over, does its thing, mines it into a block, and it's on the chain. Really important. Then we have the UTXO layer. So the UTXO layer for us is the language of the blockchain, but it gives us this a mutable data point on the blockchain that is locked to that particular token or that transaction. It's locked. The way that we deal with it is the keys are linked back to the owner, so there's a proof of legal ownership of the tokens. It's really important. If I'm a bank, that token belongs to me. I know it's locked with my key. I can recover it. I can see what's going on. I can see the state. I can see the history of it all the way through. And I get my atomic settlement, my instantaneous value exchange between my assets and my cash. And it gives us that fine-grained privacy and auditability. It's very scalable. I can run millions of these in parallel and point to any single one at any point in time and see what's going on, which is very different from the account-based approach that EVM-based blockchains take. And then under that is what we call clean coins, but we use coin-based outputs. So in the UTXO protocol we use, it's the Bitcoin protocol. The miners are rewarded every 10 minutes for mining a new block, and that's where the transactions get packed. As a reward, they get something called coin-based outputs. Those are original, clean Bitcoins that we buy, and it gives us a source of UTXOs we can use. So we've got known provenance of the data packets we're putting on chain. A Bitcoin is 100 million Satoshis or UTXOs that we are going to use. It means I've got clean provenance of the source of those UTXOs. I'm going to talk you through tokenized settlement. This is our system on a page. We'll talk through this in a minute, but very briefly on the far side, I've got our CDM lifecycle engine that's doing post-trade. The important thing you need to know about a trade is it's a bundle of rights and obligations. You and I form a trade. We're obliged to make certain payments. It talks about the specific assets, the cash, the government bond, and it talks about SSIs, which is standardized settlement instructions. That's what comes out of it. That's all automated. That gives us a canonical settlement instruction. We've onboarded party A and party B. We have our enterprise class wallets that are backed by HSMs there. That's where the UTXOs are managed and the signing happens. And then we get into a process which allows us to effectively immobilize real-world assets at custodians. So if I've got my government bonds, they are held by central securities depositories or custodians. I want to immobilize that. I want to immobilize my cash, create tokens that represent them on chain, do the atomic settlement, synchronize the CSDs, the custodians of the banks, to make sure we've updated that. They own the title of legal register on those assets. We temporarily transfer that right to the blockchain, and we transfer it back immediately. So the tokens do not persist. Once they've resynchronized, I'm going to burn the tokens. They don't exist. They were unique. They existed for a few seconds. The settlement process is tokenized. It's atomic, and I can synchronize at speed, which really reduces the friction to getting to the finality of the settlement phase. I've got a video that's going to show you this. This is 5 minutes. Try and keep up. There's a lot in here. You're going to see a trade instruction going to Tokenovate. You're going to see the synchronization of assets moving around on a CSD in a bank. These are mock CSDs and banks. They're not real. They're just for demo. But I'm going to talk you through the whole trade process as it happens. So hopefully this is going to work, and it does. So what you're seeing here is I'm setting up a trade between two parties, Horizon and Vantage. I've set up my London blockchain trade ID. What I'm doing is a repo trade, which is I'm going to sell securities and buy them back at a future point with some interest. Repo trading is very common in financial markets. So this is basically saying I've got a 9-minute window. The ISIN is the asset I'm going to trade. And you can see there it's a £500 million trade we're going to do. There's the trade instruction that's been generated. You don't need to worry about this too much, but these are the economic terms of the trade. And they've been injected into my system. So this is Tokenovate. You can see here the details. So I've got Vantage and Horizon as a buyer and seller. You can see that there's a £510 million purchase price on my £500 million worth of government bond. And you can see when it's going to happen. Everything is done in our common domain model language. It is a language model that encapsulates the economic and legal terms and drives our settlement process. Every event we put on a blockchain, so this is Public Blockchain Explorer, so every trade event, not even settlement things, ends up on a blockchain. And what we're showing here is, this is going to show, that's what a Merkle root looks like. It's a cryptographic hash, it's just a complex number. It means nothing to anyone in the outside world, but if I go back to my system, I have the data and I can match the two things together. You've just seen purchase happen, so this is vastly accelerated, but the purchase leg has happened. And what you're seeing here is at the top, you've got your cash leg, where the cash is moving from Vantage to Horizon, my payer and my receiver, and the security, which is a debt security, it's a bond identified by the ISIN, £500 million, has moved. The times are the same. It's atomic settlement. It's happened on the blockchain. And then I'm going to show you the money having moved. So these are the assets. So I'm looking at Horizon. What you see here is a bond. It's been put on hold. It's immobilized. It's debited. I've immobilized the asset and I've debited it. It's because it's gone into someone else's account. And what you're going to see is it arriving here. So it's arrived. I get a credit into the account because I'm the buyer. And I can see it being remobilized, which means that £500 million bond is now mine to use. I've got the liquidity. It happened in seconds. The other side of it is the cash. So as Horizon, I was selling the security, so I want to finance some other transaction. You can see the cash going through exactly the same thing. I've got my £510 million. It's come in. I'm ready to go. I'm going to spend that. I'll come back later on, and I'm going to repurchase the asset for the £510 million plus a little bit of interest. It's a very small amount of interest for this because I ran this trade yesterday, and I did the initial purchase and the repurchase 9 minutes apart. So you don't get a lot of interest in this. But what you're seeing here is the separate trade instructions, the trade settlement events happening. Again, it's CDM. It's all anchored on a blockchain. And if we wait, what we should see, hopefully very quickly, he says, waiting, is that the repurchase will happen. And you should notice the repurchase price has just come in. And you can see the interest there is £1,007 on my £510 million. And that was the 9 million. So we calculated that based on a specific rate that was put in. You can see it's all happened. So at this point, you can see the repurchase is exactly the same, apart from the cash is coming back from Horizon, who received it in the first place. It's been paid back with the interest. And the security, that £500 million worth of the bond, is going back to Horizon. So I've effectively loaned that asset and got some cash for it, and then reverse the transaction. And again, just to show you what's happening here, we're looking at Vantage receiving the cash, so it's getting credited, but you can see the £510 million is coming in here. And so at this point, you've effectively completed the settlement. And more importantly, you've finalized the transaction. So we talk a lot about finality in transactions, and it's always a gray area in blockchains. With us, the finality always sits outside the blockchain, because the real world asset is ultimately the asset. The legal title transfer happens off chain. This is an atomic settlement, so you can see on the left there are a bunch of inputs. There are two inputs here for the two tokens. One is the cash token, and one is the security token, the token that represents the bond. And there was a chunk of change at the bottom, which is paying the miner for the transaction. What you can see here is it's the same Merkle root. So I'm showing the Merkle roots coming across. There's inputs and outputs on the transaction. The thing that's happening here is the change of ownership by unlocking and re-signing the tokens with the cryptographic key that represents each party. And that's it. That trade matured. You've seen a repo for £500 million. It happened in less than 5 minutes. Repo is a real product. This is production grade. It's ready to go. We're pushing this tokenized settlement protocol. It's got real value because a lot of assets aren't being put on chain. You read a lot about tokenization of real world assets. The reality is the world isn't there yet. This protocol enables you to do it, but it also enables you to do it with digital assets, because you create the similar digital twin. You're tokenizing the digital asset, digital twin, and moving that around, which helps us in our move to T0. So we're at T+2 at the moment. There's regulatory and legal requirements to move to T+1 by October 11th, 2027. So bringing settlement times down from 2 days to 1 day. We're in a time machine saying you can have T0 today because of what DLT and blockchain brings you with a tokenized settlement protocol. So this enables that market infrastructure, those capital markets, to move forward, to be ready for that. It changes the way that we do trading, we base it around standards. The common domain model is the standard. It's based in a legal framework. It is a standard that's accepted by the industry, so you can drive standardized settlement workflows across both traditional markets, which we've seen today, but also digital markets. So when we get into native digital assets, the same thing would work. And it helps with the liquidity problem that we see. So that real-time movement meant those assets were available immediately rather than waiting days to get them, which means that that money can be put to work. That makes capital markets more efficient. And it means that we all do better off of, because the banks and the institutions are all a lot more efficient, so we get more for our money. So everything is based on a contract, but what if every contract knew what to do next? I'm Steve, I'm the CTO from Tokenovate. We have a booth right in the middle, I can see it from here, it's a lovely blue color. But if you want to find out more, there's a QR code for our website. Myself and my esteemed colleagues will be on the stand this afternoon, so if you want to come and have a chat and find out more, please do. Thank you very much.